Good afternoon, everyone. Can you hear me? Are you able to listen to my voice? Okay, Ganesh. But still the strength is very less. I'm waiting for more to join. Okay, let them join meanwhile. We'll start. Okay, all of you see here. So we are discussing about inheritance, and in the previous class we have gone through several examples, and hope you are clear. And meanwhile, if you are having any doubts, you can make it clear by placing in the chat box your queries, and or else you can ask to your individual faculties as well. Okay, so the next concept. Okay, last. I hope you might be remember. So this is the last and destructors, the order of execution of them. So we discussed about this, and the next concept, the last concept of your third unit, first part, is virtual base class. Okay, now one thing you people have to keep it in mind from this concept onwards, virtual. You should be very active. Your mind should be so active because the concepts will be little required mental thinking power. I mean, you have to be so active while I'm teaching in order to answer or in order to understand. Okay, now please listen. Now, see here, look at this figure. Now class A, this is a base class, and B and C up to here, this is nothing but hierarchical. And then, now what we can see here, from B and C, you are having next derived class from B. Now, D has been derived from B and C. And for B and C, you are having one more base class called as A. Now, when you are having a common base class for two derived classes and again something is deriving from them, that means suppose this base class what you are trying to inherit is having multiple parts of execution. Now, I can access, now suppose I would like to inherit B and C. Okay, now B is inheriting A, C is inheriting A. That means a copy of A exists in B, a copy of A exists in C. Are you following? So listen. Now you can see here B and C both have been derived from A. Yes or no? What it indicates, a copy of A exists in B, okay, and a copy of A exists in C. Now, when you go with D, now what we are doing in D? I am trying to inherit. When you are going to inherit A, when you are inheriting C, you are going to inherit A. That means what it will happen? It will inherit now. D will have two A's. One is from B's and other is from C's class. Is it fine? This is a figure, okay? Now, what happens now? Now, when you try to inherit like this, when you try to inherit A, when you try to access the properties of your A, it will lead to ambiguity. Okay, it will lead to the ambiguity. So, in order to avoid that, what we try to do, we will introduce a concept called as virtual base class. Okay, what we will do, we try to introduce a concept called as virtual base class. That means whenever we try to inherit A, we try to make that base class as virtual. Okay, when you try to inherit A in C, we try to make that A as virtual, so that only one copy of A will exist among B and C. Okay, when you try to access from D, only one copy will be reached from either from this path or this path. Only one copy it will reach up to D. Are you following? Let me unable. Guys. Okay, just now I received some message that you are still taking quiz. Is that completed? See, these concepts are very important. Everyone has to attend because I do the class. Okay, I will wait for 2 minutes because the solution, the execution, and you people must be active. Okay. We'll start. I hope you are done with this. Now see here. Just now what I explained. Those who join now, just look at here. Now the concept of virtual base class. Now why we require this particular concept is nothing but, now if you see the observe this particular figure, you are having a base class A, and these B and C is are derived classes, and D is also derived class. Now when I try to access D, then A can be accessed in from the path ABC, or it can be accessed from ACD. So from D you are able to access two A's, and that means two duplicate copies of A exist. Okay, inheritance, through inheritance. So now what happens like that? It leads to ambiguity. Now you can see the definition. An ambiguity can arise when several paths exist to a class from a same base class. So in order to avoid that, what we try to do, we try to introduce a concept called as virtual base class. That means when you are inheriting, you try to inherit by making that base class as virtual. That means at this particular level, you are trying to inherit A, and at this particular level, you try to inherit A. So what you will do, instead of inheriting simply as public A, what we will do, plus, that means virtual public, we try to include a keyword called as virtual, so that it will make our base class to be inherited as virtual base class. Okay, voice is breaking. 1 minute. Let me connect to other network and check it. Harshita, now it's connected to other network. Let's see. Okay, now let's I will show how the ambiguity arises and how to resolve that using virtual base class. Okay, now look at the example. It replicates the figure. Now see, what is the first base class you are having? A. Next, two derived classes are B and C, and the next level you are having D. Okay, remember this. Now is it clear, Harshita? Voice? Okay. So, okay. What I try to say, see here, when we try to access, when we try to derive class D, then it exists two parts. One is A, B, D. That means A is a base class, B and C are the derived classes, and D is a derived class. Okay. Now, when I try to inherit A, then B will inherit A and C will inherit A. Now, class D. When I try to inherit D, then what will happen? It will by default inherits A, B. It will inherit C, A. That means a two copies of A comes, one from this path and other from this path. So when you try to access the information regarding A, then it leads to the ambiguity. Okay, that means it has to identify from which path it has been accessed, or the base class information, it leads to the ambiguity. So what we will try to do, we try to introduce a concept called as virtual base class. That means while inheriting itself, we try to make this base class as virtual, so that only one copy can be one copy can be accessed either from this path or from this path. Okay, now let's see the example so that it will be clear. I'll tell you. Now first only remember this example for what is the first base class we are having A. Next derived classes are B and C, and next level you are having D. Now see the example. How it leads to ambiguity. Now class A public I, that means just I am taking a variable called as I in class A, and next you are having two derived classes B and C. Okay, B, if you see this figure, B is inheriting A. So what is the way we will inherit class B colon public A? It indicates that B has been inheriting A. Okay, in this I am taking a variable called as G. And next you can see the figure, C also inheriting A. So how you will inherit A? Class C colon public A. Okay, you are taking a variable called as K. Now, later, what is the next level you are having? D, which inherits B and C. So now see here, how you will inherit both the classes? Class D colon public B comma public C. Now here what I am taking a variable called as in sum. And one thing you can observe, all the variables whatever I have took, those are public. That means that can be accessed throughout the program. Okay. So in main, now if you see here, okay, if you see here, what I am trying to do, I am trying to create an object for this class. That means using D, I should be able to access I, that means A is variable, B is variable, C is variable. Okay. So B dot I, that means first I am assigning values to the variable and trying to do sum, calculating the sum and just printing all the values. Okay, that is a program. So if you observe here properly, now here we didn't introduce any concept called as virtual. Just it's a normal program based upon the figure. Now it has to raise an exception that it is ambiguous. Okay, you cannot access A as it is, raising an ambiguity. Okay, now see here. See, we got an error. Look at the errors. Request from member I is ambiguous. That means just now I told you, when you try to access the same base class from multiple paths, then it leads to ambiguity. So in order to avoid that, what you have to do, you can make our base class as virtual so that only one copy of A exists among the multiple paths. Okay, one copy of A will exist among multiple paths. So wherever A is there, in all particular, whenever you are trying to access I, which is belonging to A's class, it leads to ambiguity problem. Is it clear? Is it clear? Following? Now we try to resolve that, okay? So this is a problem, it is arising. Now what it is happening? A we try to access till D, so it leads to ambiguity, the same figure, okay? Now, how we will try to resolve? By introducing virtual base class. Virtual base class means during inheriting, here we will make it as virtual by placing a keyword called as virtual public A. Then here again virtual public A. Okay. Now when I make it like this, then what will happen? Whenever it might be either 2 paths or 3 paths or several paths, only one copy of A will be transferred up to the next level of your derived class. Okay. That means here you can see, that means in the next level D, only one copy of A will be accessed. Now see the execution. Now we should not get any errors. What is the error? 1 minute, I get the comment. Now see here, you can see the output. Whatever the values I are saying here, I 10, J 20, K 30, the sum of all the values 60. Okay, we are calculating and printing in a sequence. Are you following? Any doubts? Let me know, is it clear? I want more replies. Nobody should sleep as it is lunch time. Yeah. I want you people to have to practice along with me so that it will be more understandable. Where is this notes? 1 minute. Okay, good. Then next concept. So this is the same example what I executed. I presented here. Now next one. We're moving on to the second part of your third unit. Virtual functions and polymorphism. Okay, we're done with the inheritance. Now it's time to move to the next concept, polymorphism, virtual functions and polymorphism. Virtual base class is different from the virtual function, and by using virtual function, we are making polymorphism possible. Okay. Now let's go, and these are the various concepts what we are going to see here. Static and dynamic binding, virtual functions, dynamic binding through virtual function. That means each and every concept is interrelated to each other. So now you can see here. Now before we enter into the next level, static and dynamic binding. Before we enter into the concept of what do you mean by binding, what do you mean by type of object? Static type, dynamic type. We are having two types. Now, if the compiler takes care, or when you declare an object, and if you are writing, suppose if you are writing the code and compiler decides what type of object it belongs to, then it is related to your static type. Okay, and if compiler does not know what type of object it is referring to, that means it will wait till the execution of the program. Then you call it as a dynamic type. Okay, static type means the decision will be taken during compilation itself. Dynamic type means it will wait until the runtime. Okay, that can be a blind idea. So now you see this example, just a skeleton part of it. One, you are taking a class A and next one class called as B which inherits A, and in main A star B, I am creating a pointer variable, that means pointer object for my class A. Now P equal to new B. Now at this particular point of time, A is pointing to, P is pointing to A itself. So this you can call it as a static type. Okay, this it has to become up. So at this particular point of time, P belongs to A. Okay, now P equal to new B. That means later on it dynamically changes the type. That means you are trying to rechange from A to B. So it related to your dynamic type. The decision is waited until the runtime. So now We'll go in detail, don't worry. Now, what do you mean by binding? Binding is nothing but association of a function call to a function definition or value to a variable. So now, when you have different functions like suppose add, display and so on, function definitions. Now when you are calling a method, that means in main you try to call the methods. Now when you call a method in main, to which function it has to go, that you call it as a binding. It has to have a match with that particular function definition, then it will execute. So that matching you call it as a type binding, or association of a value to a variable. When you are assigning some value to a variable, that also you can call it as a binding. Okay. Now what do you mean by static and dynamic binding? So already just now I told you, if the function invocation is nothing but function call. Function call binds to a function definition based upon static type of objects. That means based upon during the compilation time itself, if you are deciding what type of the object to which that function belongs to, then you call it as a static binding. That means at the compilation time itself, you are going to decide what is the function that particular object is going to call. Then you call it as a static binding. That means compilation time itself you will be knowing what is the function definition you are going to call. Then you call it as a static binding. Dynamic binding is nothing but it waits. That means that a decision will be awaited till runtime. That means the object has to will not be confident enough that what is the function it is going to call until the runtime. Okay, you can also call it as static binding is also called as early binding, and it is generally possible with your normal function calls or function overloading or operator overloading. So these are the three things that comes under the static binding. Normal function calls, whatever the programs we have done till now, so that all comes under the static binding, and function overloading and operator overloading. Okay, now when comes with your dynamic binding, it is done during runtime and it is achieved with the help of function pointers and virtual functions. Okay, now you can read the definition. I will give a minute. Done. Okay, I'm moving on. Now look at the example. All of you please concentrate. Now look at here. First see the left side part. You don't study anything. Okay, now look at what I am saying. Now you are having base class B. In this way I am having a function called as f, and the derived class D which is inheriting base, and I am having a method called as G. Okay. Now in main I am creating an objects for two classes, base class as well as derived class. Now if you see this line, base B, I mean B small b, base class object. Now it indicates if it is not having any inheritance, it's a single class. When I try to access, now in this particular class, how many functions I am having? Only f. So b dot f means which function it will access? B's f can be accessed. Okay, just you have to link. B means you are creating an object for your B's class. Now b dot f means it will call B's f. Okay, now next I am creating an object for D. It's a normal inheritance itself, what we came across before. So D. Here what I am trying to do, I am creating an object for D. As D is a derived class from B, now D will have F as well as G. Okay. Now D dot F means it will try to inherit B's F. Okay, we will get this F from B, which is inherited one, and D dot G means you will get D's G, which is added in your D's class. I hope this example is clear. Okay, now come to this overridden method. Already in the previous class we came across the overriding. Okay, the same concept. Now in B I am having F, and in D also I am having F. That means same method is present in your base class as well as in your derived class. Then what happens when I try to access the same method? Already we have seen if same method is present in base class and derived class, then base class method will be overridden in your derived class. So the same scenario applies here. Base B dot F means it try to access the base F itself. Now I am creating an object for D. D dot F means what will happen? Already F of B is there. The same F of F method is being overridden in D. So it try to access the D self, which try to mask. That means mask is nothing but hidden generally. Base class function will be hidden or overridden by your derived class method. If the same method with signature is present in your derived class as well. Okay, this is about static binding. That means during compilation time itself, it will decide what is the method it is going to call. Okay, so now whatever the programs we have written till now, that all comes under the static binding. Okay, just that you keep it in mind. Now we'll come across the dynamic binding. This you concentrate. Now look at here. Non-virtual method, virtual method. So virtual methods concepts come into the picture now. Generally, virtual method you are making it possible with pointers or reference variables. Okay. Now see here. Up to here it's saying B is having a function F and D is having the function F. Now up to here it's saying I created an object for B and I created an object for derived class D. Now one more thing. I am creating a pointer variable for your base class. All of you listen. See here. I am creating a pointer object for my base class. Okay. Now in the next line, you observe carefully. P equal to ampersand B. What it indicates? What is B here? When you answer what is B? Yeah, I'll I don't understand what. ఎవరో ఏమో చేస్తున్నారా అని Yes, Ganesh, I do observe that. I think other faculty members are also are online. I don't know which some settings have been modified and it got closed. So now we'll resume the session now. Guys, I will give 2 minutes. Ask everyone to log in again. Ask your friends to log in. Just inform because I don't have any contact with you people. Just inform your team classmates. Okay, see here, dynamic binding. Hope now you are able to see the screen. Now see here. Observe these two lines and can you respond what you are going to observe. Before I explain, please go through the code and let me know your observation.
Okay. Have you answer? Okay, I got it. Okay.
Please all of you go through the code. I gave you time to go, please go through the code and if you observe anything, you can post it in the chat box. Any difference, if you understand anything in both the programs. Using non-virtual and virtual because this total unit will surround around this concept. Completed? Now, what is your observation from these programs? Both the programs. Yeah. What you are going to observe from both the programs. Shrita, give me answer. When we want to execute base class function, we make the subclass as virtual. Yeah, we didn't make any concept called as function. Base class function. We are not making the classes as virtual. Here the virtual functions comes into the picture. Okay, see here. Now, subclass function. No. Now see here. Observe carefully because later on I will pose some questions you have to answer. Okay. Now look at here. You are having the same method in base class as well as derived class. Okay. Now P equal to B. Now if in this line, in this particular line, P belongs to base class itself and B belongs to base class. So if you try to access with help of pointer variable, then you will use the arrow symbol, okay, instead of dot. So P of F. If you try to call P of F, then it will by default call the base itself. Okay, because reference is base class and object is of base class. So you will call base class method itself. Now in the next line, P is base class and D is nothing but derived class. Yes or no? Now base class reference is pointing to derived class object. Listen all of you, what this line indicates. Base class reference, P belongs to base class, D belongs to derived class. Base class reference belongs to derived class object. When it happens, now if it is a non-virtual method, then it will work with your reference variable. Okay, static binding takes into a picture. That means it will not relate this particular thing. That means ampersand B it will not take into the consideration. What is the object reference variable you are trying to point out? That particular class itself, it will try to access the method. Okay. Now P, here you can see binding is decided by the type of pointer. Now type of pointer, what is the pointer variable you are having? P. It is belonging to base class. Now what it will happen? If it is a static binding, if you are having non-virtual method, then it will decide upon the pointer variable itself. That means P is related to your base class. So when you try to access P of F, it will call the base class F itself. Are you following? So it will call the base class F itself. Now it is related to the non-virtual. Now here comes the concept of dynamic binding or polymorphism. What it indicates. Now see here, I am introducing a concept called as virtual method. What is in the virtual method? Now if you see here I am declaring my F as virtual function, and in D, and again I am overriding, I am taking F, I am declaring F as virtual function in D as well. That means what happens with your virtual method? Actually, in the first level, if I create it as virtual, then in below classes, how many classes it will be derived from B. All the below classes levels, this F method will act as virtual itself. Okay. Now here I made my F as virtual. Then in below level classes, it will take as virtual. This F can be taken as virtual. Now what is the virtual method? Now you see here, up to here it will be same. Only the difference exists here in the last line. So if you observe, let me explain these two lines again. P star P belongs to base class. Okay. P equal to ampersand B. Ampersand B is, this is also P. So base to base. Base to base means only this particular class we are having. So directly base class F will be accessed. Okay. Now in the next line, P belongs to B equal to ampersand D. Now if you observe, P belongs to base class and ampersand D belongs to the derived class. Now base class reference is pointing to your derived class object. Okay. That means base class reference means it will go to this base class itself. Then it is pointing to derived class object. Now when you have this derived class D, then do you have a method called as F in your derived class again? Now see here, I am having a base class B equal to derived B. So now when you happen, then what will happen? It will go to the base B and derived equal to ampersand D. Now if you observe this D. When you create an object for your D, then what will happen if you are having same method in F as well as in D? Then base class method will be overridden in your derived class F. That means D is having F. Now P equal to ampersand D means what it will do? Instead of accessing the B's F, it will try to access the P's F. Okay, that means with the combination of virtual function and pointer variable, what it will do? It try to access the decision of the method will be delayed. Which method it has to bind, it will be delayed during the runtime, until the runtime. So if you don't have the F in the below classes, if B doesn't contain this F, then directly B's F only it will call. Now in D, again I am having F. So what it will do? When I assign like this P equal to ampersand D, it will call D's F. Are you following? Once look at the program now and let me know any doubts. If you have any notes, let me know. So what is the use of virtual function? So everything you again have the concept of virtual function we will be learning in detail. Okay. One minute. Is it like without virtual? Calling based on object type and with virtual based on type of objects address. Yeah, that's all guys. Here you can see here P of, okay, summary, look at the summary. I'll explain the summary. P of F belongs to P of F. Okay, binding is decided by the type of the pointer in static. Okay, now dynamic binding, P of F binds to the B of F for B's object and to D of F for GT's object. Now binding is decided by the type of the object. What do you mean by the type of the object now? Here the type of the pointer and here is nothing but the type of the object. Type of the pointer is nothing but to which star P. Generally it refers to the type of the pointer. Okay. Type of object is nothing but generally it refers to the whether it might be it is a normal pointer, that means just like P or star P, and it should be a combination of a virtual method. Okay. If you take either pointer or reference variable, it will work. If you try to access the same with the help of normal variable, that means suppose P equal to B instead of ampersand B. 1 minute. Okay. We are having time. Right? Let me clear you. So. Right, 1 minute. Control and instead of going with all this. Okay, next slide we are having. Okay. The same program we'll try to do. I will explain this one. Okay. Okay, better you type along with me so that it will be clear for you. And choose combinations. What is a skeleton? Class B. So public B. What I should do? Let's declare public colon. Now virtual void F. So now int main B. B is equal to ampersand B. P of F. Now P equal to ampersand D. P of F. Okay, see here. Concept dynamic binding, right? Now look at here. So how we will be knowing whether it's B or C? Let me write a C out here. B is F. Okay. And here I will write D is F. Right? Now look at here. So here, look at here now. If you might be having, all of you, I mean, I'll tell you the combinations. Now see here. If you observe this properly, this is nothing but a pointer. This is normal variable. This is, I mean, B is nothing but a normal object, and this is a normal object, and this is a pointer. Now, what it indicates? Now, virtual function or dynamic binding will be possible only with the help of the type of the pointer. Type of the pointer means it is possible with the help of either pointer or reference variable, and with a combination of virtual function. Now, if it is a normal variable and if it is a virtual function also, it acts as a static type. Okay, and if it is a pointer variable and if it is a combination of virtual function, then it acts as a dynamic type. One thing you need to remember here: normal object plus virtual function, you will get, I mean, it will be static type. Okay, and either pointer variable or reference variable plus virtual function, it will lead to the dynamic type. Okay, now you can see the definitions whatever we give you. Conclusion point: Mainly it will depends upon the type of the pointer. Type of the pointer means generally it tried to, here you are having a pointer variable, but still what is the type of the pointer it try to access? D of f, is it a virtual function or normal function? So it makes a difference when you go with your static binding. And type of the object, it indicates the combination of both the values, whatever I explained. That means pointer value plus virtual function. It comes under the type of the object. Okay, that means it is having some internal sense. Now, just now I told you, suppose if it is a normal variable, okay, b is a normal variable, p is a normal variable. Okay. So let me know before I do some combinations. What are any doubts? Any more doubts? Is it like without virtual? Ganesh, is the same doubt, or do you have anything else what you posted? Sridhar, with the help of virtual functions, we will make the runtime polymorphism possible. Okay, so it describes the scenario. That's all. Now, all of you, what you will do? Take okay, you want without virtual keyboard. Okay, I'll show you this. Okay, I'm removing virtual. First you see, remember the output of this. Okay. You are calling these F and these F. Okay. Okay. Do you want me to remove both the virtuals? Virtual or only single virtual? Both. Okay. See, you can see the output. Okay, I will show you the combinations, don't worry. First I remove both, okay? I remove both. Then already I told you, if we remove both, in the previous slide, okay, in PPT itself, this one, okay, similar to this one. If we remove both, this is the figure, right? Non-virtual method. Then what is the output you have to get? B self, B self. So are we getting the same? See, B self. Because the decision is not retained till runtime. It underscores that. Okay, next. Okay, what is the other one? Only these virtual you would like to remove. But you will get the same output, Rahul. It will be reflected in the next classes. Okay. Virtual. Now this is you would like to see, right? See. Okay, if you remove these virtual also, it will work. Okay. Now what happens here, I will tell you. Here it is virtual. In next level of derived class, this method will be taken as a virtual. Okay, in the next levels, if any change is there it will go for the other reflections. Okay, 1 minute, I'll show you what makes a difference. We are having so many examples later also. Okay, now look at here. Here, before, just now, here I am having virtual in line number 6 and in line number 12 I don't have virtual. Okay, now what I did, here I remove virtual and here I place a virtual. Now what is your output? Will you get same BSF and DSF, or will you get BSF and BSF? Yes, good. Now you can see the output be safe. Now what should be our conclusion now? Look at here, all of you, carefully. Now see here. Now this is a first in B, it's a non-virtual function. Okay, in D I am making this function as virtual. Now in next level of classes, suppose later on if I am having multi-level inheritance or any other, so in next level of classes this F will act as a virtual. Okay, suppose if I am having class D which inherits D, then if same method is overridden there, then it try to access the method from that particular class. Okay, see, class E which inherits public D. Okay, I will not write total for your understanding. Okay, this is ESF. Okay, one more level. ESF. Now it is particular. Let me remove virtual because once we made virtual, it acts as virtual throughout. Okay. So now see here I made it virtual. Now till now what it is, it's a non-virtual function. In the next level it acts as a non-virtual function. In D we made it as virtual. So when I try to create an object for my D E and access, then it will check. Now here you are having D, right? I will show you 1 minute. Let me create one more step. This is E. Okay, E. Now what I should do? This E I should be able to access. Now what I have to do? What is the way of accessing? Base should access deriver. Okay. Now what is the base? D. D equal to ampersand E. Okay. Now D equal to ampersand E. Okay. Now what I have to do? D or yeah. Now what we have to get as output at this particular point. In the next level, this is made as virtual. So it will go with the next level checking. Okay. Now you have to get this as output. Let me check it out. I insert semicolon. What is the error? What? Yeah, star E, right? I'm unable to see the error. What I do? I think it should be star. What is the error, ma'am? It should be star D. Okay, star D equal to E. D equal to ampersand E. D of F. I hope it should be a correct. Let me uncomment this because we are not looking at this. Now see here. Okay, this is what I would like to show you. Okay, now look at see. So what I am trying to show, Now here at this level, what you are having? F acts as a static. Okay. Now at this level, you are making this method as a virtual. So in the next level, it tries to check for the below levels. That means it will go with the any other F is present in your derived classes. Then it will try to override it or access that part. So here at this level, you are getting E as output. So see here, are we getting this E colon F? Yes. So in the later examples, again we are having an related to this. So like we know, if you are understanding only up to one level, it's well and good. In the next coming examples, you will be learning in more detail. Don't worry. Still any more doubts? I think who asked me this one? Is it clear for them? Any doubts? Okay, it will be a combination of virtual and pointer or reference variable. Then it acts as a runtime polymorphism, guys. Okay. Now, actually, I would like to on the program, but please you complete after this. I would like to ask you. This one, what you'll do is that, okay, I'm not going to discuss this now as we are running out of time. What you'll do, take a screenshot of this. All of you take a screenshot or take a pic of this screen. Okay, hope you're done. Next, this one also. Take a pic. So, what I want you from you people, both of you, see, all of you just go through this example and try to execute and try to analyze the program. And we'll discuss in the next class, tomorrow's class. Okay, done. This will be the next concept. Continuation of today's only. So here we are taking one thing you need to observe. Here we are taking normal variable, pointer variable and reference variable. Okay. This reference star PV refers to pointers. Okay. This ampersand RB refers to your reference space. Ampersand RD refers to reference derived. Okay. Try to analyze this and please be ready by the next class, and I will on one program try to complete that 1 day later. I think it's already started. You can attempt it. Static binding. Okay. And if you are having any doubts, you can post here in the chat box meanwhile. And this one also you can practice with combinations. And if you are not clear, it will make it clear for your concept. Yes, good. Yeah, that's what it will do. What it will do, if virtual will check for if any method is being overridden in the derived class, then it will try to access the derived class method. If not, it will try to access the base class method. So the decision is when the decision for which method you are going to access is awaited till runtime. Okay, as it is a virtual, it will wait till runtime, whether it has to access either base class method or derived class method. And it is not compulsory that in the next level itself it has to get overridden. You might be overriding the same method in 3 to 4 levels. Then it will check whether it has been overridden in next level or not. If it has been overridden, then it will access the derived class. If not, it will access the base class. It is one type of dynamic binding or one feature of polymorphism. You want the PPTs? Actually, the material will be shared at the last. We'll be forwarding you the notes